everybody, Walter Pullman here on this gorgeous fall afternoon, and we're in one of the coolest places in Burlington, right here on the Burlington Waterfront. Looking out towards through the Burlington Harbor, across the lake to the Adirondacks. We are here at the Leahy Center for Lake Champlain, and we have a great moment with the Executive Director, Phelan Fretz, to learn a little bit more about this place and its importance for lake management and really interpretation of the whole ecosystem here. Thanks for being here, Phelan, on this beautiful afternoon, looking over this really beautiful but complex ecosystem. And I wonder if you could just tell us a little bit about the background of this whole center down here and how it relates to the management, the education, the interpretation, the study of this place.
You know, it actually is a world-renowned resource, and it's because of who is actually situated here at the Leahy Center. You know, you'd have to go back 25, 30 years for folks to understand when folks were looking at the Lake Champlain and going, you know, we're in trouble here. We got to make a big step. We got to take a bold step in order to be able to fix it. And so at the Leahy Center, we're basically talking about is three legs of the stool. First is the Ecosystem Science Laboratory of the Rubenstein School, right next door to us. And so without them, the research and the monitoring that's so critical to understanding the ecosystem would not be available to us. The second is the Lake Chaplain Basin Program, which many folks know as sort of this monitoring and management group funded by the EPA and many other federal agencies. Their job is to make sure we're all coming together, thinking about this together, but also making sure that the monitoring is being maintained year to year to see how we are doing. And then the final leg of that stool is education. You can't do all this research and all this monitoring if you're not communicating it to the public. And that's where ECHO comes in. So our job here is to take that information from all the monitoring from the UVM research and the whole system here. There's 9 colleges, of course, that all feed that information base, and then figure out how to communicate that to the public on a regular basis. And we do that by seeing 170,000 people here on the waterfront, education programs, everything from camps to daily programs to you name it. We try to do it here as a way, using our toolbox, to educate.
Well, it's a great partnership, and I know people from around the world come to be educated about it. Can you tell us a little bit about the displays and interpretation approaches that you take here in the ECHO building itself? Yeah,
you know, what's so fascinating is so how do humans learn? And in fact, that's my science. When you present an idea or you present an action or an experience to a human, how do they build a concept of that? How does that become part of their being and that they can carry it forward? Well, there's sort of 2 fundamental ways we do it here. One is live animals. Live animals enable you to tell a story that's unprecedented. When you stand in front of our sturgeon tank and you watch those 5-foot sturgeons swim by, you get the size and scope of what this lake's about. Or you see the walleye swim up, or the muskie. You know, you're looking at these different kinds of animals, and each one of them has their own story. And for me, it's always really interesting whether, you know, I've got a herpetologist in here and they're taking a close look at some of the frogs or the turtles, or I've got a fisheries person and they're staring at that tank. They're all sort of looking at it from the same way that the public is. What's the story behind that animal? How do we as a culture have to support that animal in its stewardship? And that's the stories we tell utilizing these animal ambassadors. So we've got about 60 species in the building, 2,000 animals in about 20,000 gallons of water to be able to deliver that every day. So that's the first. The second is, for humans, it's about what are you going to do? How are we going to engage this thing and engage this body and engage your heart about how important this stewardship is of this great basin? We do that with interactivity. And so that's the creativity of my education and exhibits team, is how do you take that information and turn it into a 3-dimensional experience where you're challenging someone to sort of figure it out, because we don't want to just give them the answer, because you learn better when you got to muscle through it yourself. Through that process, you're learning the essence of what's going on there. So it's about interactivity, about what you can do, how we're going to push you, how you're going to experiment yourself, but also the live animal stories just are amazing. Recently, we've taken to, with smaller groups now, of course, in this era of COVID, we've been able to do some very interesting kinds of experiments. And one of those is with live animals. We've actually started an exercise program for our live animals. So when you come here, you watch the turtle walks across the floor, or a frog jumps. Because those animals sit in a small enclosure, they're not getting the exercise. They need it too, right? They're a live animal. So there's always ways we're looking at how do we support the animal, its stewardship, its care, but also using the natural behavior of that animal to communicate its importance and the value, and then to push folks to think about what are their personal actions about stewardship of this great basin.
Fantastic. You know, one of the things I've really appreciated about ECHO over the years is that how you showcase diverse perspectives on the lake as well. And I just sort of wonder what the trajectory you guys have with that.
You know, diverse perspectives for us means a lot of different things. It's meant, in the last year, we do Sensory Sundays, which are about how does somebody on a learning spectrum, or someone who has auditory issues, how do we create a space where they can learn, where it may need to be a little quiet, where the light might need to be low, so how do they in that space? Or we're the family place where the whole community celebrates Martin Luther King Day. And so 2,000 people come here, and we mix sort of that conversation around racism, what does it mean to be an integrated community, but then also what does that integrated community do in stewardship of this great environment that we sit in.
Well, Phelan, thanks so much for the great work you guys are doing here at ECHO, and for inviting us here into your place today.
Walter, it's always a pleasure. We love that NR1 comes down here and utilizes this as a platform for the kinds of things that you're involving students in. Really pleased.
Hi, I'm Chris Brooks. I'm a lecturer at the University of Vermont's Rubenstein School of Environment and Natural Resources, and I'm here today on the Burlington Waterfront at the Rubenstein Ecosystem Science Laboratory. We really are forming a research hub and partnership focused on the health of Lake Champlain. It's such an amazing resource that we need to protect, really the ecological crown jewel of our region. The lake here is really a primary economic driver for our state of Vermont in terms of tourism. It provides hundreds of thousands of people with fresh, clean drinking water, and it provides all of us with a wide range of really awesome recreational opportunities. But this amazingly beautiful lake also has some really significant water quality problems today. And the primary culprit is nutrient pollution, primarily in the form of phosphorus. Phosphorus is a chemical element that's essential for all life. It's all around us. It's in our bodies, it's in the soils. Plants need phosphorus. But if you add too much phosphorus into a freshwater ecosystem like Lake Champlain, there can be an explosion of biological growth and algae growth. And that's what's been happening here in Lake Champlain for many years. That's a process called eutrophication. Too much phosphorus entering the lake results in these algae blooms, some of which are really harmful algae blooms, particularly occurring in some of the shallower, warmer bays of Lake Champlain, like Missisquoi Bay and St. Albans Bay, areas of the South Lake and elsewhere, where the algae blooms are in the form of cyanobacteria, otherwise known as blue-green algae. And cyanobacteria is toxic to humans, it's toxic to wildlife. It results in a decreased availability of oxygen in the water, which impacts the whole ecosystem. Certainly all of the animals and plants and aquatic life that rely on the lake for habitat. So it's a really, really significant problem, and it turns out that it's a very challenging environmental problem to address. And a big reason for that is because the vast majority of the phosphorus that's entering Lake Champlain comes from diffused surface runoff from a variety of different sources across the landscape. The primary source of phosphorus in terms of the percentage of phosphorus entering the lake is from agricultural practices in our state. Runoff from cultivated croplands, runoff associated with all of the manure that's produced as a part of dairy operations and other livestock operations that ultimately has to go somewhere, and when we spread it across the land, it eventually enters the lake. But it's really too simplistic to say, well, agriculture is the biggest percentage of the problem, therefore the solution is to target only farms with new regulations and get farmers to develop nutrient management plans. That's certainly part of the solution, but there are a host of other sources of phosphorus across the landscape. So phosphorus is coming off of the forest lands in Vermont. Up to 21% of the phosphorus entering Lake Champlain is from forests. Phosphorus is entering the lake as a result of stream bank erosion. So particularly along streams and rivers in Vermont where we don't maintain adequate vegetated riparian buffers, the banks of the rivers lack stability, which results in increased erosion, and all of that sediment that's being eroded out of rivers and streams has phosphates bound up in it that eventually enter the lake. There's phosphorus entering from wastewater treatment plants, from point sources, where we're treating human waste, municipal waste. There is phosphorus entering the lake right here, like on developed land throughout Vermont, particularly in the Burlington area, where the human-built infrastructure creates so much impervious surfaces in the form of buildings and rooftops and roads. That results in a lot of stormwater, which contains phosphorus and ultimately enters the lake. So everyone here at the Rubenstein Lab and the Eco Center and Lake Champlain Basin Program, everyone working on these issues wants a healthy lake, and we all want a vibrant and sustaining agricultural system in Vermont. And there's just no simple fix to this problem. And so for many, many years, the state of Vermont, working in conjunction with the Environmental Protection Agency at the federal level and a host of other public and private groups, have been working towards a better comprehensive plan to address nutrient pollution in Lake Champlain. And that work has often been really contentious. There's been a lot of contentious debate about the proper course of action as between all of the various stakeholders around our lake. It involved lawsuits, so litigation has been in part driving efforts to clean up the lake under the Clean Water Act. And ultimately, the state, working with all of these groups, has come up with a new plan. And that plan under the Clean Water Act for cleaning up impaired waterways is something called a TMDL, a Total Maximum Daily Load, which is, simply put, a pollution budget for phosphorus entering the lake. The TMDL dictates how much phosphorus can enter Lake Champlain on any given day and still allow the lake to meet water quality standards set by the state. And that TMDL is primarily being implemented by a state statute, which the state passed in 2015, and it's called Act 64, otherwise known as the Vermont Clean Water Act. And the state legislature here and the state agencies that implement the regulations under that act have adopted what they call an all-in approach, an effort to strategize and address all the sources of phosphorus entering the lake across the landscape. And so the new TMDL and Act 64 are certainly a step in the right direction towards addressing nutrient pollution, but it's still an issue and there's still so much more work to be done. And so here at the Rubenstein Lab, in conjunction with the Eco Center and the Lake Champlain Basin Program, is a place where UVM students and faculty and staff are studying the lake health, they're monitoring the health of the lake, and they're working on new strategies to mitigate against nutrient pollution here in the Lake Champlain Basin.
Hi everybody, Walter Pullman from the University of Vermont, and today we're down at the shore of Lake Champlain on the Burlington Waterfront at the Rubenstein Ecosystem Science Laboratory. And I'm really pleased that today we have the opportunity to chat with Captain Kirsten Collins of the RV Melisira. And just great that you're here, because I wonder if you could just tell us a little bit about this vessel that you're on.
So we are here in Burlington Bay at the pier. We're right adjacent to the Rubenstein Lab at UVM. So this is the RV Melisira. We're a 45-foot research vessel. It was built in Maine in 1986 and has been used by UVM ever since.
Fantastic. Could you tell us a little bit about the equipment that you've got on board? Looks like some cool stuff.
Yeah, absolutely. So right next to me here we have a CTD, so conductivity, temperature, and depth sensor. We send this down throughout the water column to collect various data. We send it to a predetermined depth. So that's sort of a common activity on board. Right now we actually have a NOAA buoy on board as well that was sent to us from Ann Arbor, Michigan. This will soon be deployed and used to collect wave data, to include wave period, wave height, and do a trend throughout the season. Just to point out a few obvious features of the vessel, we have a large A-frame crane that we can send various equipment over with, to include all of our trawling nets, and then 2 hydraulic winches available to us as well.
Can you tell us maybe a little bit about the research questions that UVM faculty and graduate students and even undergraduates are asking that they use the Melisira to help answer?
Sure. So this past summer we've been busy bottom trawling, mostly at deep depths, normally to 40 meters to 60 meters of water. We've also done plenty of mysid collection as well.
And the Melisira, I've heard a little bit of a rumor that it's 33 years old, it's reaching a retirement age. What's the future hold for the Rubenstein Lab in terms of research vessels?
We're excited to announce that within the next year or so we're going to have a new research vessel. We are going to be the green research vessel of any university. It's going to be a hybrid propulsed vessel, aluminum construction and a catamaran style hull.
Good. Well, hey, last question. What's your favorite part of your job so far?
I love getting up at sunrise. Usually we go out deep water trawling early in the morning. This is the most beautiful place on earth to work.
Well, thanks so much.
Thank you.
One of the key partners in the stewardship of Lake Champlain is, of course, the Lake Champlain Basin Program. They just do a tremendous amount as it relates to education, but particularly monitoring of the state of the lake and how it's changing through time. And I'm really pleased we have with us today Laura Hallowell from the Basin Program, and specifically she is the Resource Room Coordinator. And Laura, what can you tell us? What is the Lake Champlain Basin Program all about?
The Lake Champlain Basin Program is a watershed-based partnership that works in New York, Vermont, and Quebec to protect and restore the lake and its human and natural communities.
Excellent. In terms of this whole idea of the state of the lake and sort of the monitoring functions, can you tell us about that? What's the state of the lake all about?
Well, the state of the lake is one of our key pieces of outreach material that we have here. It comes out every 3 years, and we thought we needed to bring it to the public. So we now have this beautiful outdoor State of the Lake exhibit where we look at how the lake is doing, but also how it's trending. So it's not just the state of the lake, it's also important ecosystem indicators that tell us how the lake is going to be in the future, or how we might be able to create the state of the lake that we would like to see.
Yeah, and what is the current state of the lake? Somebody asked you that.
I usually tell people that we've had some real successes in terms of protecting the lake and its water quality and wildlife, but that we have some pretty serious challenges. One thing we're seeing is increased nutrient pollution and runoff going into the lake, both because of development but also climate change. We're seeing often more rainfall, not this summer, but often more heavy storms. One thing that cyanobacteria or blue-green algae needs to thrive is warm, calm water. With temperatures increasing, both air and water temperatures, we're going to have to work harder to make the lake more resilient. And one of the main things we can do is reduce polluted runoff going into the lake.
Got it. Well, I love this new outdoor display, but I was first drawn to the Basin Program because of the fact that right within the Leahy Center for Lake Champlain, you have a resource room for the general public. What's it all about, and what do people come there to do?
Well, the Basin Program is all about partnerships, not just with federal agencies and state governments, but with research institutions like UVM, with conservation organizations, and luckily for us, with the Eco Science Center here on the waterfront. So we couldn't have a better spot to take the excitement that's generated here at Eco and the curiosity that Eco visitors have. We aim to get people to think about how they can learn more, but also get involved. So the resource room is always staffed by Basin Program staff. It's open to the public, the same hours as Eco, and we provide a lake and watershed library. We have exhibits, we have hands-on activities. It's an all ages room, so we have plenty of things for kids to do. Complete library that covers not just lake issues, but fish and wildlife, recreation, history, cultural heritage. We have information on the native peoples that lived in this region. It's just an amazing resource, and not just for Eco visitors, because the public can get a pass to come into the resource room, and of course, UVM students are always welcome to come and use our resources.
I know it's been a terrific resource place for our UVM students to do when they really want to dive into questions about the lake and really the complex social ecological systems that here. And what are the linkages between people and this amazing resource?
The waterfront's a great place to be because we have this human story here. The history of the waterfront is amazing. We have views of Waterfront Park and Burlington Bay from the resource room. So we're very place-based, and we are very interested in how this landscape formed, starting with, a billion years ago and the geology of the Adirondack Park, all the way to the human inhabitation and to this day, the changes that we're seeing, even right now on the Burlington waterfront with the bike path under construction, or with other changes that we see right here in Burlington, the trains coming in. It's really exciting. I feel like we're at a crossroads. Literally too, this can be a really busy area. We have tourists, we have locals, we have students, all converging here, and it's just a great place to do education and outreach.
Well, thanks for being right at the center of this crossroads and for all the great work you're doing with the Basin Program.